Today we're in Ruskin, Florida at the National Weather Service, where we're going to meet with experts who are going to talk to us about weather patterns and how hurricanes are formed, and of course what it means for you and me. So sit back, relax, and join me on this science quest. Hi Dan, how's it going?
It's going good, welcome.
Thank you. I'm here with Dan Noah, the Warning Coordination Meteorologist for the National Weather Service. Now Dan, what does that actually mean? What do you do here?
Well, I'm one of the few people in our office that actually get to work with our external customers in the media and your local county emergency management agency.
And what does that mean, working with the media and the... How do you work with them?
National Weather Service warnings and forecasts don't mean anything if people don't hear it, or if they hear it and they don't know what to do. So the media are the ones that communicate the message, and emergency management are the ones that prepare the community.
So you're taking the data and you're disseminating it, basically.
Disseminating the forecast, but also interpreting the forecast for the decision makers.
Okay, great. Well, I would imagine taking all that data in, analyzing it, getting it out, takes a lot of different technologies and sciences behind it, right?
Yeah, we get to work with a lot of really cool toys, and I'd be glad to show you around.
All right, let's go. Now, Dan, we're here in front of the array of screens, and I'm seeing a lot of things going on. What is it that I'm looking at right here?
Well, we have a lot of different instruments to monitor the weather. When we're looking at the big picture, we're looking at weather satellites and weather balloons and maps, that kind of data. But as the storms roll into the local area, we're going to switch over to the Doppler radar to see how that storm is evolving as it passes through.
Now, when we talk about storms, we're not just talking, I mean, you guys are tracking all different kinds of stuff. It's not just, we think of the National Weather Service when hurricanes come rolling around, but the truth is you're actually doing a lot of things all the time.
That's right. We have a lot of high impact weather that doesn't really seem severe, like sea fog. When it rolls into the bay, it really impacts the Port of Tampa operations, and the cruise ships can't get in. We've had super fog events like we had in Polk County in 2008, where the visibility just goes to nothing and we have a lot of collisions on the interstate. So we're working with the Florida Highway Patrol to give them a heads up when we think that's going to happen.
So you can actually track things as minute as fog.
Right, and also the dry season people think our weather is boring, but we have some of our long-tracked violent tornadoes in the dry season. It doesn't happen often, but when it does, it happens at this time of year.
Some of the most dangerous weather that you can think of. Now, you had mentioned Doppler. Now this is these are like the giant white spheres that we see 100 feet up on towers, right?
Right, Doppler radar gives us the inside of the storm. It tells us not only where the precipitation is, it tells us which direction the wind is blowing. With the upgrade we did recently to dual polarization, we can now tell what kind of precipitation. Is it sleet? Is it rain? Is it hail? Is it bugs? Is it birds? We really have come a long way.
Wow, that's incredible. How does it actually work? I mean, I understand that there's a dish inside that kind of rotates, but how does that tell you these different things?
Well, rotating the dish at different elevation angles gives us a three-dimensional picture of the storm. We can actually rotate the storm around and go inside of it to see how that storm is evolving and if there is possibly a tornadic circulation.
Wow, that's incredible. Now, like I said before, when we think, especially those of us who are inland, we really don't think of the National Weather Service until we need them, when a big storm is coming. Let's talk about hurricanes a little bit. How does a hurricane form? I mean, how do these massive storms develop?
Well, if we look at the image behind me, there are an average of 86 named storms across the world each year. In the Atlantic Basin, that's all the way from Brownsville, Texas to Africa, that's 5,000 miles, we have an average of 12 storms a year. And hurricanes are nature's way to take excess heat at the equator and move it to the poles. The atmosphere around the globe does not like imbalances, and hurricanes are one way to fix that.
Huh. I never really thought of it like that. So a hurricane is basically, because when I think of a hurricane, I think of a storm that is a local thing. It's passing through, it's just something that's affecting us right now, but it's really part of a much bigger scale.
It is, and if we look at the difference between the number of hurricanes in the northern hemisphere versus the southern hemisphere, the north has a lot more hurricanes. And the reason for that is we have a lot more land that's blocking the sea currents, and the heat is piling up, and Mother Nature doesn't like that.
Very interesting. Now, there are ways that a hurricane forms. How does it actually happen?
Well, there are several things you need for a hurricane to form, but the main ingredient is the fuel for the storm, and that's warm ocean temperatures of at least 80 degrees Fahrenheit, about 200 feet deep.
Which is mainly why we see these storms really grow through the Caribbeans and through these warm water areas.
Yes, earlier in the season we tend to see the development in the Caribbean. As we get into August, we're looking closer to the African coast because now the Atlantic is warmed up. And our hurricane season is June through November because that's when the water is warm enough to create the fuel for the storms.
Now, how does 200 feet of warm water actually fuel a hurricane? Because the hurricane is happening, in the air.
Yeah, that's a great question. The wind blowing across the water not only creates waves on the surface, but it creates a vertical current that goes down. And what goes down, something has to come up. And if the warm water was too shallow, it would actually bring cold water up to the surface, and that would limit the hurricane's potential.
I see. Now, you had said that there were several elements that a hurricane requires. First of all, the warm water. What are some of the other elements that
Well,
it
what we
requires?
saw in 2013, why we didn't have that active of a season, is a lot of dry, dusty air was blowing off the African coast in the mid-levels of the atmosphere. So it was actually too dry in the mid-levels for hurricanes to develop. We actually need it to be more moist.
How can you actually see all that? What's some of the technology that's used to build these sciences?
There are two main things that have really increased meteorology, the science, over the last 50 years. And the first is weather satellite. Satellites give us information over the ocean surfaces, which cover 2/3 of the planet, and we didn't really have information from there before. The other thing is computer power has just gone up exponentially over the last 10 years and allows us to do a lot more simulations of the atmosphere. So with the weather satellites and the new supercomputers, that is really giving us a lot more tools.
Now, you'd mentioned the satellites. Is that one of the reasons why we're seeing so many more named storms? It's not that there's actually more storms developing, but...
Right. Satellites have only been around for a little over 50 years. So before 1960, if the hurricane or tropical storm did not impact the shipping lanes, we didn't know about it. So if it was in the south central or southeast side of the Atlantic, we wouldn't know about the storm.
When you'd said about the computing power, when you see an image of a storm, then it's time to analyze what you're looking at. How does the computer take up an image, a satellite image, and predict where that storm is going to go?
Well, between the satellite images and the weather balloons and aircrafts that are flying back and forth, gathering weather information, we put all that information into the forecast simulation.
Okay.
And on a real general sense, if you're a bag of air and you're 50 degrees Fahrenheit, you're moving at 15 knots, where are you going to be in 2 minutes? Well, you do that at numerous levels all around the globe, and you just are moving the atmosphere and developing the weather systems.
So it's not that it's analyzing just where the storm's at, it's actually taking a big picture, a global picture, if you will, and analyzing everything that's factoring into these air currents and movements.
And we're taking that information and then we're actually forecasting it out into the future. And it works really good out to about 5 days, but you get out to 7 days, things get iffy. 14 days, I wouldn't use it.
And I'm looking at this this image. It almost looks like a satellite type image or a radar image, if you will, of a hurricane coming through. Tell me a little bit about what I'm looking at here.
What we did with our new computer power is we ran a computer simulation here locally on Hurricane Charley, and this is the radar image of the results. And if this would have occurred, it would have been so much worse for the state of Florida. We would have saw devastation in our coastal counties all the way from Fort Myers up through Tampa Bay, all the way to Jacksonville. And not only just from wind, but the storm surge would have inundated much of the coastline.
So even with the technology that you have, sometimes these storms have a mind of their own.
Well, that's the thing, Mother Nature keeps us humble. There's a lot we still don't know, but we're getting better.
Yeah.
And with Charley, it actually did take a small right-hand turn into Punta Gorda, and it acted more like a 12-mile wide F2 tornado. It didn't act like a hurricane.
Yeah.
As I was going through Orlando, the airport had 105-mile-an-hour winds, and people were walking on St. Pete Beach and looking at stars. That's not a normal hurricane.
Now, when I look at this model of Charley, I see that the rotation seems to be going counterclockwise.
It is, yes.
Is that always the case? Does every hurricane turn the same direction?
Every hurricane and typhoon in the northern hemisphere goes counterclockwise. When you get into the southern hemisphere, they're actually rotating clockwise.
Now, why is that? Does that have to do with the gravitational pull, or just the way things?
It has to deal with the Earth's rotation, and it creates something called the Coriolis force. And basically, it's just what side of the coin you're on.
Yeah. Now, I'm also seeing some different colors involved in this radar image. Tell me a little bit about what the colors mean and how the hurricane kind of develops width-wise.
Well, a hurricane is a giant heat engine, and it's sucking up heat and humidity into the storm to feed itself. The green colors that you see are light to moderate rains in the rain bands. The reds are the stronger storms. It's in the outer rain bands that we worry about the tornadoes. As you get closer to the eye wall, we're worried about the eye wall, and we don't have many tornadoes.
Now, the eye wall, as I'm looking, there's hardly anything right in the center of, you see the red, and then it quickly scales back down to basically nothing right in the middle. Why is that?
Well, in fact, the center of a hurricane, you actually have sinking air, and the winds really become calm right in the center of the storm. And so it's really in those bright red eye wall bands where the strongest winds are. So now this is a Category 4 storm, and if a Category 4 storm is coming toward, say, Polk County, we can't tell you if the eye wall is going to go through the county or not. It may miss the county, and you may only have Category 1 winds, even though it's a Category 4 storm.
Now, you said that it has air sinking in the center. What does that do with is that how it kind of continues to fuel itself, the constant sinking and then drawing in of other higher air?
Well, the eye wall itself is just a big area of low pressure, and that's what's pulling in. It's pretty much vacuuming in the heat and humidity from around the storm. And the sinking air in the middle is just to equalize and balance out the hurricane.
Okay. And again, that's where it comes into play, the temperature of the air, the low pressure,
Right.
high pressure, and the humidity involved, the humidity around the storm, right?
And again, it's Mother Nature's way to grab that heat and displace it to the poles and get it out of the tropics.
Very cool. Now, with the intensity of the precipitation, the red area around, when we think of a hurricane coming in, obviously we know of, storm surge and the coastal regions that just get nailed with flooding. We always see it on
Right.
TV, and those waves are coming crashing in over the beaches and into houses. But the truth of the matter is, the rainfall from these hurricanes, as we've experienced here in Central Florida, is a major cause for concern.
If you live in Florida in the summer and you see heavy rain, we get flash ponding. We don't really get flash flooding. But now with hurricanes, 95% of our flash floods are with tropical systems. So not only are you have to worry about the wind, you have to worry about flash flooding, washing out roads. We saw one fatality on Highway 60 near Lake Wales after Hurricane Charley because water was covering up the hole in the road and the person just drove right into it.
There's also the wind factor, and you touched on tornadoes at the tips of the hurricane, but these hurricanes, as they grow in size or intensity, can really bring some wind.
Right, and the worst part of the wind is going to be in the eye wall. So if the eye wall doesn't hit your house...
Now, when you say the eye wall, you're talking about the area that is right around the eye.
The
right
center
around
of the
eye.
storm. Yep,
Okay.
that rain band right around the center of the storm.
That's where we saw the red, all the precipitation.
Right, so if you're watching TV and you're seeing that eye wall's headed toward your town, you've got to hunker down, do everything you can to protect yourself from flying debris. If it's a major storm like Charley is, it's probably going to rip your roof off, especially if your house was built before 2002. The building codes weren't as good as they are post 2002.
Is that what we're looking at here?
Yeah, if we're looking at some of these images, the top floors of older apartment buildings tend to get ripped off. So if you live in the top floor, don't stay there. Once wind gets inside of a house, weird things happen. It pops the roof, and you can see the car is fine, but the rest of the house is destroyed. It really becomes just do whatever you can to protect yourself. Yes.
Wow. Now, what is it that causes the intense winds? I mean, we talked about the vacuum. Is that what is causing that circulation to increase so much?
Well, the energy inside this giant heat engine we call a hurricane, you have this massive suction power. So that's part of the wind. But also in these storm towers that are around this eye wall, they're dropping these monstrous water balloons down at the ground one after another, and that's intensifying the winds in that eye wall.
Interesting. So it's actually it's almost in a way fueling itself.
It is, and it's not going to end until it hits it runs out of fuel.
Which would be over land, because as long as it's picking up warm waters off of the ocean, it's going to continue to grow. But it's when it gets over the land is when it starts to slow down.
That's what we tell people, but we saw in Hurricane Wilma that it actually intensified over the Everglades. So every time we try to pinpoint something in Mother Nature,
the Everglades kind of
is water.
Yeah, kind of. You got a different kind of situation because you've got very shallow, warm water, a lot of moisture there for a hurricane to pick up.
And with Florida being a peninsula, you could have a hurricane hit the Gulf Coast, decrease a little bit, get back into the Atlantic, and then intensify again.
And we've seen that happen.
We have.
Okay, so hurricanes are coming across the ocean, and they're smacking into land. Probably Florida. Florida or Texas. We seem to get the brunt of these things, and the Caribbeans, obviously. But one of the biggest concerns is the storm surge for those coastal regions. But, I mean, we're talking about a massive amount of water coming in. What is it that causes these giant waves to just come in and destroy everything?
Well, in 2013 in the Pacific, we saw Typhoon Haiyan hit the Philippines, brought in a 20-foot storm surge, and just devastated some of those islands. We can get that in Florida as well. It's the wind blowing across the surface of the water that starts to pile it up, and as it gets towards shore, it starts to increase in its level, and it's the power of moving water that can just wipe barrier islands clean.
Wow. So it's actually, it's not just waves, it's actually almost like a disbursement of water as the hurricane comes in. It's pulling the warm water out of the ocean and into the hurricane.
It's actually piling the water up on itself. So if you blow across a hot soup bowl, you can see the water piling up on the other side of the bowl. That's what the hurricane is.
And then almost creating a lower area where you're blowing. Same thing with a hurricane.
And moving water is heavy. If you had a fish tank that's 3 feet by 3 feet by 3 feet, you fill it with salt water, it's going to weigh 1,700 pounds. And if it's moving at you at 20 miles an hour and you try to stop it, what's going to happen? Now imagine you have billions of these fish tanks pushing against block homes on the barrier islands. They don't have a chance.
It's so interesting to talk about weather, to talk about hurricanes and tropical storms and tornadoes, because the sheer force of Mother Nature is just mind-blowing. Okay, so the hurricane is on its way. You've been telling counties ahead of time, okay, this is what we're looking at, this is the potential path, we're looking at winds that are going to reach, over 100 mile an hour, whatever. The counties have to be on their toes, right?
It's interesting, we'll forecast not only the weather, we'll forecast the impact. So if we're seeing 100 mile an hour winds with gusts to 120, that's going to cause a certain amount of tree damage. And emergency management has to plan on how to clean that up and open the roads and get the electricity back on, get people to hospitals. So it's really emergency management takes the bulk of the responsibility to protect life and property in their communities.
They're really the, you've got kind of the science behind it, but they are the folks that take the science and actually apply it to the residents?
They are managing the emergency, and the emergency responders are the boots on the ground actually doing the work, and we have to worry about their safety as well. So we got to get them off the streets during the worst part of the storm.
So you're working with Polk County on a regular basis, so it's not just when hurricanes are on their way.
People say, oh, you had a busy hurricane season. Well, actually our workload decreases during hurricane season because we're waiting for the storms. It's before hurricane season that we're the busiest. We're working with hurricane exercises with the local emergency operations center, making it as realistic as possible so they can test their systems to make sure everything's working.
Yeah.
And in fact, now's a good time to maybe head over to the EOC and see how they work.
Excellent. Well, thank you, Dan. I appreciate it.
You bet. Thank you.
Hey, Billy. How's it going?
Hey man, how are you?
I'm doing good. I was just over at the National Weather Service, and they sent me over here. I was talking with Dan Noah, and he had said that, they're doing all the tracking of the hurricanes and everything, and then he takes that information and sends it off to local municipalities and counties like you. Mm-hmm. What exactly is it that you do with the information that's provided to the counties?
Well, I have an email list every morning around 5:30. I send out the local conditions, advising people and different agencies of what's anticipated in the day. I try to give them a 7-day forecast out, show them the local conditions, but also such as hurricane season, I'll start sending a tropical update following, and send out what we call fire weather, which shows the KDBI drought index, which is the Keith Bynum drought index, and it shows the duff layers. It shows how vulnerable we are at different stages of the game, and so that plays a very important part to public safety, towards firefighting, towards wildfires or whatever.
Now, you said duff layers. What is a duff layer?
Duff layer is the foliage that falls off. It's a certain layer of the dead foliage that falls off during the wintertime.
Okay.
And it builds up a layer, sort of like a layer of mulch. And whenever the relative humidity gets down a little bit below 35, that's when even a catalytic converter pulling over the side of the road can start a forest fire. And that's whenever because the air is dry. There's literally no humidity to put out the fire.
So you're actually tracking all kinds of different weather patterns, not just storms or major issues. You're even tracking things as minute as humidity.
Yes, and we stay in the back most of the time. We like to stay in the background. We do give the different agencies. It goes to a lot of people. It's quite an extensive list. It's well over 5,000 people.
Wow. Now, so basically what you're saying is not only do you receive the information from Ruskin, from the National Weather Service, but you're also monitoring. So if you start to see something, it's a two-way street. You're
yes,
we
do in disasters, whether it's man-made or natural. It could be anything towards a chemical incident also. So it's a whole wide range of things that we're constantly looking at.
Well, I would imagine, honing all of this weather information down to a specific area like Polk County. Although Polk County is a very large area, it's also a very specific place.
Yes.
I would imagine that gives you the opportunity to be able to kind of give these reports on a very defined portion.
Yes, and sometimes the weather, if we start seeing some rainfall coming in like we have today, we have a lot of operations. It's not emergency management or maybe not fire, but maybe it's the skids and the portables. If we start having convection, that's a severe thunderstorm. School board will then pull the students out of the portables and put them into the main. It's all about safety.
I see.
And but we don't need a particular event going on, which is maybe outdoors and somebody's susceptible to lightning strikes. Because we well know,
so like a
lightning,
baseball game
yes.
or something like that. Well, this is great information. Now, when the big storms come in, obviously there has to be some type of plan that's in place. Who takes care of developing these strategic emergency plans that you guys do here?
Paul Womble, he's over the programs. He's the program manager. Him and Pete McNally, and also they will pull in other agencies to all gather and say, this is our comprehensive emergency management plan. We have different different inputs, so it's just not one agency that's putting that all together.
Well, that's I'd really like to go talk to Paul then about how these emergency operations take the information that you're gathering and use it to keep the community safe.
Yes, very
All right.
good.
Well, thanks, Billy.
Thank
Appreciate
you. You take care.
You too. Hey, Paul, how's it going?
Good, how are you?
Good. I just talked with your buddy Billy, and he was talking about the weather patterns and stuff that he follows, and then you guys take it and make different emergency plans for
Right.
the county. Tell me a little bit about some of the strategic planning that goes into these operations.
Well, our plan is based really, they're all hazards plans. So it's really all about roles and responsibilities with a large county, with 17 cities, constitutional officers, and the Board of County Commissioner staff. How do we all work together, whether it's a hurricane or a severe weather threat, or as we've seen with cold weather?
Right.
All those things are part of our plan.
And of course, you have this terrific facility here, and there's a huge room. What is the purpose of a place like this?
Really, the purpose of the Emergency Operations Center is really coordination of planning. Day to day, our focus here is planning, training, and exercises. And that involves government, nonprofit, private sector, really anybody that has a duty or a role in an emergency. So if we are faced with an emergency, then our role really becomes coordination. If in a hurricane type scenario, this is the command and control facility of the Board of County Commissioners. State of emergency would be declared, and we bring in all the partners. Emergency management's role is really to facilitate the response, but we can't do it without all the folks that would come into this room.
How much effort goes into, year-round effort goes into staying prepared?
Well, it is a year-round effort. We have different threats. Hurricanes have some notice. Tornadoes, severe weather, most of the time has very little, if hardly any notice. So again, when there's short notice events, what do the agencies do? How do they work together? Right. Everyone has different, whether it's statutory requirements, local requirements, federal requirements. There's a lot of overlapping jurisdictions. So how does everybody work together with the goal being a coordinated response, positive outcomes for the citizens of the county? That's really the goal.
Yeah. Now, I noticed on some of these screens here, you have different traffic cameras and things like that. How does that help you?
Situational awareness, what's going on in the community. If we're especially in a hurricane type scenario, at some point we roll down the storm shutters and we're basically locked down in the building and we can't see outside. So we need to know what's going on,
right.
Bring that information in again from all of our partners that are in the room through their networks and resources. But what can we see? We've got access to traffic cameras, a few of those around the county, just to give us some idea what really is going on, outside of the building.
Yeah. Now, from what I understand is, if there's a huge threat, you're going to bring everybody in here, but you also have the ability to take this on the road, right?
We do. If we do not need all the resources here of the EOC, we can, and we do. We'll deploy, especially to larger special events. We are very involved in the planning for Sun and Fun and have been for the last several years. Had severe weather there several years ago and actually brought in the Weather Service, Dan and his staff from the Weather Service office in Ruskin. Yeah. They come and they staff, provide staffing at the Sun and Fun for the whole time, and they give us weather briefings. Again, it's all about being able to know something is going to happen, get the warning out, and be able to take the appropriate action.
Yeah, well, that's really interesting. You make mention of Sun and Fun, big events that happen in Polk County like Ironman, even spring training season. I'm sure brings in a lot of people and a lot of places that things could happen really quickly.
Yeah, we have staffing at those events. We may not go out to every event. There's a lot of events that occur in this county, but knowing what the weather is of the day, check the forecast, having a way to receive those weather, especially warnings from the National Weather Service. Any event planning should incorporate some type of public safety and severe weather monitoring. Outdoors in Florida, we're going to have weather.
Yeah. Paul, this has been really great. Thanks so much for, you and Billy letting me come over here, talk to you guys about the Emergency Operations Center and how you guys keep Polk County safe. Really appreciate it.
Sure. Thank you for coming.
Well, that's about all the time we have for today. So join me next time as we seek out yet another Science Quest.